This is part 2, once again, review. So hopefully you kind of sort of remember the stuff. The second part of the review, you got into estimation of an interval that give the range of a particular parameter. In other words, parameters being the proportion, a mean, standard deviation, and so on. And so in other words, you could get some degree of confidence that the population parameter would fall within this interval, and this was the formula that you used. You should be able to look at this and say, oh, okay, I can see this is an interval about the population mean based on the sample mean minus, remember these are these cutoff critical values divided by 2 because half down here, half up here. And then the population standard deviation over the square root of the sample size. If you did not know the population standard deviation, then the only thing that happened is it changed to the t-table for your critical values, and then you just use the sample standard deviation. These were critical values very quickly that you could look up in the tables to be able to plug in here. All right, so when you got into hypothesis testing, this is where whether somebody says something, you believe them or not, right? That really the water bottles have 12 ounces of water in them. And so they came up with a null hypothesis that stated our water bottles have 12 ounces. Then you came up with an alternative, which was you don't believe them. And the two different tests, of course, depended on, again, with the confidence intervals, if you knew the population standard deviation or if it was unknown. So in other words, Z versus T. And we had the 3 different types of hypothesis test when we were looking at a single mean, where the mean equals a particular value. Again, we could go with the water bottles. The one tail, lower tail, the cutoff would be that we think if you fall in this region, they're underfilling the bottles. The one-tailed upper tail would be they're overfilling the bottles, which would be nice, right? And then the two-tail would be we care about both, right? So that's how we set up our hypothesis for a single mean. Then we got into the formula for the difference of 2 means. Now you need to review this one, and I'm going to do very quickly an example to show you the 2 sample means, because you're going to see your application, you're going to have to go back through this again. Remember with the formula, don't let all these, I mean, again, hopefully you remember a lot of these symbols, but read it as this is my sample 1, sample 2 averages. Remember the mu1 minus mu2, the hypothesis, if we're saying there is no difference, that's 0. We have our standard deviation of our first sample, our standard deviation of our second sample, and these are the population standard deviation that are given when you square it, the variance, and then the number of samples in sample 1 and the number of samples in sample 2. So if I had a problem that I wanted to test the difference between 2 wages, and so in other words, I'm going to say wage 1 and wage 2, they're the same. There's no difference. And I'm going to test this with an alpha, a critical value of 0.05. So if I want to look up that actual cutoff value, okay, so this is my significance, 0.05, and find the critical value, this is what I'm looking up in a table. And a lot of times you see the hypothesis expressed like this, because this is saying there is no difference, right? If they're the same and you subtract them, you get 0. So these mean the actual same thing. And when we look up again our critical values, what we're doing is we're saying if our answer falls within this gray area, then it's all good, right? It's no problem. But if we fall in this rejection region, then we have a problem. So remember, your rejection region is set by your critical values that you're given a level of significance, okay, and in this case being 2-tail, the difference between the 2. And so I look up this significance divided by 2. Typically it's easier just to look up this left one, which will be negative. Why? Because it's less than 0. And then I just do the positive on the other side. So in other words, if I fall within these regions, then I'm certainly going to reject my null hypothesis. So I'm given some data between advertising managers and auditing managers, and we're basically saying their salaries are the same. And so I get the number in the sample, I get the sample average, I get the sample standard deviation, and of course I can square it and get the variance for both of these. And then what I do is I take all this information and I plug it into my Z, which said my sample average for sample 1, which was what, advertising, minus my audit, was it audit? I already looked and forgot about it. Yeah, auditing managers. So these were the, each sample, the mean, the sample means. And then in this case, these were the variances and then the sample size. And I plug all that in the calculator and I get 2.35. Well, if you remember, our critical region back here was cutting off at 1.96, so 2.35 is definitely in the critical region. It's in the red, right? And so thus in this case, because it is greater than the 1.96, we reject the null hypothesis and say there's definitely a significant difference. Now, hopefully when you took this class, part 1, you set up the data analysis tool. And if you do that, it's kind of nice, and go find my spreadsheet here, because then what you could do, all you really need is the variance, but let's just go ahead and find each one of these values. So if I want to find my count, there's actually a formula called count. And so I just highlight these and then I close, and as you can see, it shows 32. I can do the same thing over here, count, and then I highlight this data, and that gives me 34. So again, just my sample size. These are my mean. I just didn't put the little bar over it. So the average of the advertising manager's salaries, and then the average of the auditing manager salaries. Okay, so a little bit of review of these functions in Excel. So nicely, they have the standard deviation. So the standard deviation and the standard deviation. And then finally, the variance. I can either use the variance formula, or I can just simply take this value and square it. Okay, so it's kind of up to you. So I can either use the variance formula. So let's go ahead and this one actually use the variance formula, which is the same as the square of my standard deviation. All right, so this now I could set up a Z and plug everything in, or I could use this, and like I said, hopefully you have this set up, the data analysis. If you don't, then what you have to do is go through the file, the options, add-ins, and then under manage Excel add-ins, you should have checked the analysis tool pack. Okay, and hopefully you've done this already, that it's already set up, but you might be on a different computer than when you actually took this class last time. All right, so the data analysis is cool because I can do a Z-test, 2 samples for means, 2 samples, and I care if there's a difference in the means. And so here now I can click and say, well, highlight, so click and drag my sample 1 data, click to come back here, click on the next one, I highlight to select, to select my sample 2 data. I put in the mean difference 0, that says there's no difference. And here I actually went ahead and already typed these in, but I could click on those, or I could get the values from these actual cells. The alpha level looks good. My output, where do I want to output this? I don't know, that looks pretty good right there. And I click OK, and as you can see that quickly, I get my Z value. So I don't have to do it manually. So this this is kind of nice. And even if you remember p-values, do you remember p-values? The probability that you would actually reject the null. You can certainly get those values, depending on one tail or a two tail test. All right, and that's it for that. So again, hopefully you kind of sort of remember this with the review. You have two samples, and you want to see if there's a difference with the mean. Finally, the last thing that I want to mention is regression analysis, where you look to see if there was a linear correlation, okay, and if it was a perfect straight line, that was a positive one, meaning that it's going up, the slope of the data, going down, -1. You probably not going to get something perfect, but these are still showing that you have a positive correlation. These are showing a negative correlation. This here looks like nothing linear, at least, is going on. And then after you saw if you had some type of a correlation, what you did is you came up with a regression equation that drew a line that was the best fit line that helped you use that equation for making predictions. All right. And that pretty much finishes up the review part. Again, I know this is very quick, but hopefully you just took Stats 1, so all of this is pretty fresh in your brains. If not, as always, ask me questions. Okay, if there's anything you have any questions on.